So today we're gonna wind up our topic on our unit on exploitation by talking about attacking systems with Metasploit. We're gonna sling some exploits today, but first I'm gonna direct you to the link at the bottom of the slide here. Make sure you get signed in. I will post that in Slack as well. Uh, but it's important to sign. We got to sign in. College of Computing still wants us to do that. If you're watching this in the recording, I don't see why you shouldn't sign in still. So go ahead and do that. So yeah, let's talk about Metasploit. Before we get into that, actually, just as a reminder, Grey Hat elections are this Thursday. There's a post in the general channel with a list of candidates and their statements. A lot of people running. Regardless of who you want to vote for, please vote. It's a good way to make your voice heard in the Grey Hat community, and it'll also, help shape what happens next year. It's your right to vote as a Grey Hat member. So today we're going to finish up our unit on exploitation. Next week we're going to start talking about post-exploitation. Tonight's actually going to really well set up what we're going to do next week, since a lot of it is going to be using Metasploit, just like this week is. So yeah, we're going to finish up exploitation. And the way that we're going to frame this is we're going to talk about systems. In past weeks, we've been focused on services. We've talked about web services. We've talked about binaries. We've talked about a couple other things. But today we're going to generalize that. And rather than talking about just services, we're going to start talking about the whole system. A lot of the things that we're going to start doing this week are going to be the kind of things that you can play with after you've gotten past the firewall. Since we're going to be looking at a lot of FTP servers, SSH, a lot of the internal services that companies use, but usually they're not things that their clients need to use. It's just what the employees are going to use. So the next week we'll go more into, once you have broken into one of these servers, how you can go and pivot, and you can go start kind of recursively traversing the network. And it's really cool how it winds up looking like a graph. So that's going to be our goal. We're going to continue talking about these techniques: injection, bad logic, and overflow. And we're also going to realize that these are kind of the general topics of how the problems work. And each service that we're looking at, since we're now generalized to looking at all of the services, it's going to come with its own set of problems. And what we're going to find is that a lot of these services, because they have their same problems in them, people have already written exploits for how to go attack all of these services, and a lot of the services fall victim. A lot of companies fall victim to people not updating their software, which makes it really easy to go sling some exploits at them. So to give a good example and to kind of frame when you would be doing this, when you would be using Metasploit, when you would be attacking systems, is when you start off in a pen test, you might be outside the network, you might be inside the network. But if you're outside, you might have access to port 22 SSH and port 443 SSL, a web service port, but you might not have access to 8080 yet, because that might be behind the firewall, as indicated by the red here. So what if you could go break into the service on 443, and now you'll be within the firewall, which is this darker orange box here, and you'll be able to actually access all three of these services. So you've extended your attack surface by changing where you're coming from inside this network. Once you go and get inside the network, you also might realize that there's a whole nother service in here. There might be a database that you've now gone into port 443 here using some web attack, and now you can go pivot off of the e-commerce website and get into that database. MongoDB databases are particularly vulnerable because by default they don't have passwords on them. So you can just go type Mongo and then the IP address, and it puts you right into the database by default. Generally with the Mongo databases, you put them behind a firewall, and they so it doesn't really matter that you don't have a password on it, but a lot of the time, if you go look on Shodan.io, which is a search engine that looks at all ports, not just web ports like Google does, you'll find a lot of Mongo databases that don't have passwords on them. And Shodan will even go and index them for you and tell you what the collections within the database are. To answer the question in the chat, these are the standard ports for all of these services. I tried to go and make sure the standard ports are being used to kind of frame it. So 8080. So 22 is always going to be SSH. You might also see SSH on 2222 if 22 is being used for something else. 443 is always going to be HTTPS. Usually when you go type HTTPS : whatever your website is, you don't have to go put the 443 in there because it's implied. And then 8080 is kind of the second port for HTTP. So you also might see 8443. A lot of the times you just stick an 8 in front of something if you want to say that maybe it's an admin port, maybe it's a development port. That's generally what that is. And then Mongo is just going to be on 27107. So yeah, so let's talk about vulnerabilities and exploits. So a lot of the time, what will happen is some really smart people will go figure out how to crack one of these services. Maybe they go find an exploit in a really popular FTP service. And a lot of the times, they'll go and they'll tell the people who created the FTP server first. They'll give them a, say, 90-day warning, which is where you get the idea of a 90-day exploit. And that gives them time to go fix it. And then they'll go and announce it to everyone to kind of further on the mission of security. Something that'll happen in other cases is a 0-day exploit. And that's the one that you hear about the most because it's saying, like, I found this exploit in Windows that lets me get admin access, and I'm just going to release it. I'm not going to give Microsoft any warning on that, and I'm just going to release it to the world. And those are really dangerous because then it becomes a race. And you see, especially with bug bounties, you see a lot of bug bounties come in and people exploiting companies with 0 days just because these people, they might not have the biggest security teams. They may have not seen it, and they just haven't updated their systems yet. I recently saw one in Jira, which is a system for ticketing. So if you're a developer, you might have a Jira instance so you can go keep track of your milestones if you're doing Scrum. And they had a 0-day that allowed you to go look at all the information without a password. And there was this like 2-week period where you just kept seeing all these companies get exploited because they didn't have their Jira instances behind a firewall and they were vulnerable and they hadn't updated it yet. And there was no update. There was no update available for the first couple of days. So generally when you have a really popular exploit, you get assigned a CVE ID. So you might see something that says like CVE 2017-065. That is a thing that the National Vulnerability Database keeps track of, and they use it, and they also have a score for how impactful these vulnerabilities are. And it's just a way for it to index. There's actually search engines. I think that's a link to a search engine, Exploit DB, that keeps track of how you can go exploit these. On Exploit DB, a lot of the time you have Ruby scripts and Python scripts that you can just go run, and it'll go exploit it for you. So one more step above Exploit DB is what we call Metasploit. And Metasploit is a program for Kali, generally. It's installed on Kali, but you can install it on any operating system. That's just kind of goes and aggregates all of these exploits and puts them into one unified program. We'll look at an example of that in a second. But first, we're going to talk just generally about an exploitation workflow. So always the first thing you're going to do is you're going to enumerate, because you can't go find an exploit unless you know what you're trying to exploit. So we go and enumerate, we figure out the software, the version, the operating system. Usually we'll go use Google to figure out an exploit because they're pretty well indexed as they're public things. And then we're going to figure out how to run the exploit. You can use Exploit DB and just run the Python script. You can write your own. You can use Metasploit. And then we can go start recursively doing this again with post-exploitation steps. And we're able to go pivot. And hopefully what will happen is as we're into our network, maybe we have low-level access in this first exploit we just did, and then we can get a little bit higher, and we can just work ourselves up the chain, and ultimately we can go get God access to this network. So now we're going to introduce formally Metasploit. It's a framework that lets you do it in Ruby or even Python, and there's even a GUI for it. So let's do a demo of Metasploit getting used here. Let me share my screen. Are there any questions so far? I know there was just one in the chat here. So we're going to fire up. So this is a Kali command line here. And I have a system called Metasploitable up, which is a virtual machine that has just a bunch of different services with vulnerabilities rolled into it. And we're going to go through the whole process of exploitation here, and we're going to go exploit an FTP server. So the very first thing that we do when we're trying to exploit something is we're going to just go ahead and run nmap, and we're going to let that go, and we're going to see what we can find here. And hopefully it doesn't take too long to do this. The TAC A tag is an aggressive scan, so it's going to go not only tell me that there is something up on the port, but it's going to try to give me a little more information about what's going on. So we're going to scan this Ubuntu machine here, and eventually it'll pull something. While we're waiting on that, I'll go ahead and get I'm going to stick that sign-in link in the chat real quick. Oh, there it is. Make it a little easier to go fill that out. Oh, and I guess another thing on the arbitrary versus standardized ports is you can go put it on whatever port you want. That's called security by obscurity, putting something on a random port in order to go hide it. Generally, that's not the most secure thing to do. It's a good step in the right direction, but something like nmap, even if it's on a different port, it can go fingerprint what you're looking at. Another kind of more clever thing as an aside that people will do is they'll go do this thing called port knocking, where the first time you go check a port, nothing's up. But if you go try like port 1000 and then 5000 and 3000, and you do it in that order, it records what you have hit on the order in which you hit those ports. And then after you do those three, the firewall lets you in for 30 seconds. That's a slightly more like interesting way of doing services. I did a CTF that had one of those problems, and it was pretty cool. Okay, so anyway, our nmap scan here has a lot of things on it. Like I said, this is a virtual machine that has a bunch of things rolled into it. Hopefully everyone can see this okay, by the way. Let me know if you cannot. But the first thing we're going to see here is that we have an FTP port on port 21. Port 21 is the standard port for FTP. FTP by default is not encrypted. It's just like having a netcat session up that has FTP. I think we had a lab problem a while back with something like that. Port, I think 23 is a secure version of FTP. So let's go. So Nmap was able to figure out what version of FTP that we're running here. So all we need to really do is we're just going to Google it, and we see, oh, look at that. There's an exploit for this version. So we can go look at exploit DB here, and we can just get a good idea of what's going on. So you're able to go copy files over without logging in. And then there's a way to exploit it here manually. But rather than exploiting it manually, let's add the word Metasploit to our Google search. And then we get Rapid7 search result, which is the company that creates Metasploit. We could also just do searchsploit, and we get a bunch of them. And you don't only get the Metasploitable ones, you also get the ones that are just Python. But for this, we're just going to fire up Metasploit using MSF console. And hopefully that comes up on its own. There we go. So now we're in the Metasploit console. And that's going to give us a bunch of commands that we can use for Metasploit. I'll go ahead and I'll put a more in-depth guide on kind of the common commands here and the common use cases, but you can definitely come back to this video as a reference later. So the first command we're going to use here is we're going to use this exploit. So now we're, as you can see by the command line here, we're using the exploit. The main command for like seeing what's going on once you've picked an exploit to use is show options. And we can see that we have a couple options here. You can set a proxy up. Our host, that's going to be the most important one. So let's go ahead and set our host to 192. Which is where our FTP server is living. Now we should be okay. So now we actually have to set a payload. That's the next thing we have to do. So we've figured out how we're going to exploit, but now we got to figure out how, once we've exploited, we're going to be able to go get data back. So we're going to go show all of the payloads that we could possibly use here. And sometimes with these, you just have to play around with a couple. Let's try this reverse Perl one and say we're going to go use the payload called command Unix reverse Perl. Or I'm sorry, we're going to set the payload that we're going to use to command Unix reverse Perl. And then once we show options a second time, now we can see the payload options. And I'm going to go ahead and set my host here to that, which is my IP address. Now we're going to run this thing, and we realize that there's a problem. So, well, I'm going to exploit a different service then, so I don't have to deal with that. I think there's more to that website. It's kind of like Metasploitable is kind of like a CTF in itself that forces you to go and sometimes it's not the most straightforward thing with it. So something that I do know that is here is that there is a port listening on port 80. We can go map it again here. This time I limited nmap to only looking at port 80 with the TACP flag, so it should run faster. Look at that. So nmap was able to go figure out for us that there are a couple directories here just by reading through. So we're going to go check out the Drupal service that's running on our web server here. And so it looks like nmap wasn't able to figure out what version of Drupal we're using. So we have to do a little bit more enumeration here. And we should very quickly be able to figure out that we're using Drupal 7. So let's go see if there's any vulnerabilities for Drupal 7 here. And we quickly see that there are a bunch of vulnerabilities for Drupal 7. This one's called Drupalgeddon. So let's head over to Searchsploit and see if we can figure out a way we can go exploit this thing. Drupalgeddon is right here. And we can search through Metasploit as well. And we can figure out how we can go exploit Drupalgeddon. So it looks like we've got this one here. Let's try the first one. So we can go ahead and use that exploit. We're going to show our options, set our host to our target. The little nuance here is because Drupal is being hosted on the /Drupal subdirectory. We're going to go ahead and set the target URI to Drupal. And we're going to show payloads again. Let's pick PHP reverse Perl since Drupal's a PHP service. Show our options. Set the host to our own IP address. And let's run this thing. Oh, look at that. We got a shell. So now when we run ls, we're able to go see exactly what's going on. If we print working directory, we now have a shell on this Drupal server. We can see who we are. We can go change the directory. And I guess an interesting thing here is actually that if we run ls here, we see that we're looking at a bunch of PHP files. If we print working directory, we're inside the Drupal folder. We're in the folder from which the script is being run. If we try to go change the directory, then we go do print working directory a second time, we're actually still in the Drupal directory. And that's because we went and we used a, let me get out of the session here. Because we're using a PHP payload, what's literally happening every time we run a command is we're going and we're sending out a request. We've put some PHP file on the server somewhere, and we're just hitting it every time we want to make a request. So there's really no state in this. All we have is a way to go run a command and then come back. So what we've really achieved more than anything is remote code injection. We just have a really nice way that we've just packaged it up. Are there any questions on this? On our first adventure into Metasploit here? Cool. So the next thing that I want to talk about then is going to be, let me get my slides back up here. There we go. Okay, so the next thing that I wanted to talk about is Windows. So Windows is divided into two different flavors of it. You have Windows Client, which is the most familiar one to most people, probably everyone. And then you have the server version. So the server version has a lot more packed into it, but it has fewer client things packed into it. So in the server version, you might be able to go run a web server without having to go download anything. You might be able to go run a database without anything. But both of them are based on the same core software, which is MS-DOS. And both of them also do a lot of under-the-hood file sharing stuff in order to go authenticate users. So because Windows is so complicated, and because somebody figured out the statistic here is that you have one vulnerability per 10,000 lines of code, you find that there's a lot of exploits in Windows because there's just so much going on. And a couple of really famous exploits that are fun to exploit are MS-0867, which is a term that should just roll off the tongue if you're in security, is an exploit that actually the NSA came up with, and it helped them go and break into the Iranian centrifuges. So in 2008, and probably long before then, the NSA and the US government was just sitting on this vulnerability that was basically like a God vulnerability for Windows XP and then Windows Server 2008 and below. And what it was able to do was use the login protocol to go get a shell on the machine. And once you've got a shell on the machine, it's pretty easy, well, it's relatively easy to go escalate your privileges and to go get admin on the Windows. It wouldn't be root on a Windows machine. So the US government was able to go and get past the air-gapped network in the Iranian centrifuges, and then they were able to go run this program. And ultimately what they did was they ran a little special program that when overloaded the CPUs on the Iranian centrifuge CPUs, and they wound up just exploding. So this was the kind of the thing that went and gave them access. A couple years later, a hacking group called the Shadow Brokers was able to exfiltrate another vulnerability from the NSA. This one was called MS-1710. This one used a similar thing. It used the Samba file shares in order to go obtain access to any Windows machine. Eternal Blue in early 2017 is actually when a lot of ransomware started happening because there were so many machines vulnerable to this because people don't update their machines. So you had instances of not only clients and end users getting affected by it, but also businesses that were using all of these servers got all of their files encrypted, and they had to go pay an amount of Bitcoin to go and get it decrypted. So super interesting. Like whenever there's a big Windows exploit, there's always a huge wake behind it. And then later in 2017 or 2019, another exploit called Bluekeep, which affects remote desktop, which is how you can go remote control a Windows machine. Usually when you have a Windows server, if it's running like Active Directory to go manage all of the users in your organization. Georgia Tech uses Active Directory, for example, to go manage all of the students' user accounts and their passwords. That's how you ultimately wind up being able to go log on to any Georgia Tech computer and then log into the single sign-on with the same password. It also like knows what your major is, what your status is, all that stuff. But anyway, generally when you have a domain controller, which is the highest thing in an Active Directory instance, we'll talk more about this next week with post-exploitation and how to go break into a domain controller. You go remote desktop into it. That's the main use of it. That also fell vulnerable to an exploit, and you could go get in without any authentication. So Windows exploits, and particularly with Metasploit, are super important. So what's bad about Metasploit? What's bad about using these exploits and just slinging exploits that anyone else has made? Is that because they're always the same, they're really easy to detect. Any IDS, an intrusion detection system, will be able to go figure out that you're using one of these just by signature. They'll be able to see that maybe you go and maybe it ran a little bit of PowerShell code, maybe it ran a command. You can just go grep for that command in the logs, and you can just see somebody did it. And then if you're going and you're just exploiting something and you're putting up a new service and you're listening on the new port on your computer, you can also go detect that because you just say like, okay, well, I didn't have any ports open to the world, but now I have a port on port like 6666. And so it goes and flags it, and security goes and investigates and realizes that somebody has run an exploit. And so then you burn your exploit and they go patch it. So you don't want that to happen. So how can we go fix this? How can we go be a little bit more invisible and a little bit harder to detect? So in order to do that, we're going to go start talking about shells and reverse shells. So the firewall will probably catch it. And also, that's something that I forgot to mention, is that the inbound firewall will probably catch it too. If you have an inbound firewall that goes and detects things as they come into the network, that's much more likely to be hardened and secure than the stuff that's going outbound. So what if instead of going and creating a new netcat service on the machine that's inside the corporate network, what if we created a new netcat service on our computer and we just put a little tiny program on the corporate computer that goes and reaches out to our system? We can go do that over HTTP. We can go do that over any service we want, and it'll mask it. We can even encrypt it. That's called a command and control server, and that's what practically people will always use when they're creating one of these, when they're exploiting. How do we know how many vulnerabilities Windows has? So generally when Windows exploits come out, they're done responsibly. So the NSA definitely has some exploits in their back pocket that they're going to just sit on. So I guess we really don't know how many vulnerabilities Windows has, but we know how many have been released in the past. And we can probably assume that there are more vulnerabilities because the operating system keeps getting more and more complicated. So more and more vulnerabilities keep popping up. And then also you have the vulnerabilities that come up just from one service, and you have other, what I call integration vulnerabilities, that come in when you go try to connect two different services. And those are a lot harder to go detect than the vulnerabilities that are just from one service. Because you can have one protocol that's talking in one language and another one that's talking in another language, and then the edge that's going and connecting them is the thing that's broken, and then you have a whole nother like realm of vulnerabilities. Does that answer your question? Hope so. That's true that Microsoft will just go fix it as well, to answer the second part. But again, people have to go update their machines for that to happen, and a lot of the time people don't update it. With Windows 8 and above and Windows 10 and above, they have made it harder to go avoid updating things, but also people go complain because they don't want the updates to automatically go onto their computers because it might go break something, and also because people think that Windows is going to go add spyware if they go automatically do it. So the vulnerabilities in the National Vulnerability Database, I wouldn't call them I would say the older ones are kind of useless, but just because something is patched in the most recent version of something doesn't mean that people are using the most recent version of something. I worked at a healthcare firm back in high school, and they had a Windows XP machine past the date that it was no longer being serviced, and it was vulnerable to the MS0867 vulnerability. And the problem is that all these companies, we can just go update our computers and there's no harm, no foul. But a lot of these companies have business critical things running on their systems, and that makes it a lot trickier to go and update them, because you have to go update everything all at once because you can't have downtime on your network. You have to go ensure that all of these things aren't going to go break your business critical services. So it's a lot more prevalent to have systems that are not up to date than you may think they are. So I wouldn't call them useless. I've seen on Twitter like just reports of all of these like IoT, especially like power grids and that are just so critical that they can't have any downtime. There can't be any risk. They're very out of date. There's still like Windows 2000 being used somewhere in places. Hopefully that answers your question. Let me know if it does not. So another thing that you can do, kind of a step on top of a reverse shell, is you can go create a beacon. So a reverse shell goes, and every time you want to run a command, it talks back to you. But what you can do to make it really covert and really hard to find is you can, at least from a network forensics perspective, is you can say, okay, well, I'll put a little tiny program on this computer that goes and lives in memory, but every time the system shuts down, it goes and it makes itself into a file, and then it goes and it puts itself back into memory when the server comes up. So it's really hard to go find it. And then it only goes and asks, it comes back and it asks my C2, are there any new commands, every 5 seconds with a little bit of a random jitter, so there's no pattern that you can figure out. So it might be sometimes 5 minutes and 15 seconds, it might be 4 minutes and 30 seconds. And that makes it really hard for network administrators to go figure out that there's something amiss, especially if it's something obscure like a DNS packet. You can go mask your shells in crazy ways. You can go make them into Reddit posts. I've seen like IRC ones. You can make them into DNS queries that are just like meant to be domain lookups, but they actually come back with a command. And maybe they're looking up a subdomain that's the output of the command. And they're encrypted in base 64, so you can't even see that it's a command. I've seen Reddit ones. A lot of them. Can't think of any others. Twitter, that's another popular one. So yeah, that's called covert communication. And it just hides it. And so if you go and you send something over like port 6666, it's pretty easy to filter out what's going on. Or you do it over SSH. It's relatively easy since there's less traffic going over that port. But if you do it over something like HTTPS or DNS, if you're on a employee's computer, that thing's not going to get found because it's so like there's so much other stuff going on the machine. So this is just a diagram that kind of exemplifies. This is what a shell would be. Say we're listening on port 25565. And if we're the attacker, we can go interact with the command line on the e-commerce site here using port by netcatting into 25565, and then we'll have access to 8080 indirectly. But then if we have a reverse shell, it's the e-commerce site that's talking to us, and that might be over, and it's netcatting to us. That should say port 53, not 25565. Port 53 is DNS. That's the standard port for DNS. And you can see how it's going to be really masked by all the traffic that's happening. And then a beacon, it does the same thing, but it does it every few minutes. In this example, I use a HTTP request to do it. You can go post to get next command with the response of the last command response. So you're sending the previous command's response out to the attacker's web server, and the attacker is coming back to you with the next command. You kind of get this iterative thing going. We're not going to do that, unfortunately, but I will talk about it. So we're going to really get into this next week with post exploitation. That's actually where I think this fits better. But what you can do is once you've gotten into a server and you have a shell on it, you can actually use SSH to go port forward. You can go see in the example from the previous thing. Once you have a shell, you can go use the fact that you have command line privileges on the e-commerce site in order to go pivot yourself to port 8080. So you're able to go see what's on port 8080. You can also do it with the database. You could go figure out where the database is, and you can just go use the e-commerce site as a middleman to go and see what's on the MongoDB. We'll return to that next week. And here's an example of using it with a Mongo database. You're able to go tunnel yourself through port 22 and then indirectly talk to the service that's behind the network firewall. So that's all I've got about Metasploit. I highly recommend Metasploitable. It's something you can definitely spend a couple hours playing with, and that's the best way, I think, to get good with Metasploit and just kind of seeing these vulnerabilities. Hack the Box is also a very good resource. I plug Hack the Box a lot, but especially for Metasploit, it's good. It'll even tell you on Hack the Box when you're looking at the problems which systems on there are going to use something like Metasploit as opposed to like web exploitation. Highly recommend those. That's all I've got to say today. So if there are any questions, I'm happy to answer those either via chat or if someone wants to use their microphone. I'll stick around for a couple minutes for that. But yeah, thanks for coming out. Make sure you get signed in on that link that I will now post again in the chat. Remember to come out for elections on Thursday for Grey Hat. I guess pay attention to what's going on in the Slack. I'm running for president of Grey Hat, so you can go read my vision for where I want to go with that on Slack as well. But yeah, regardless of who you vote for, definitely come out. A lot of people running. There are a lot of positions that we got to fill. Yeah. Hope y'all have a great week back. Super awkward doing this on Blue Jeans because I can't see anyone's faces and I can't see if people like don't understand what I'm saying or completely understand what I'm saying. Yeah, hope y'all have a good week.